All right, thank you, Jan. I'm excited to present here today. So, hi everyone, my name is Adair Kelley, and I'm co-founder of Abstract Money, and I am here to show Abstract SDK, which is our smart contract framework, our on-chain infrastructure, as well. It's a full-stack CosmWasm experience. And so I'm going to share my screen really quickly, and we've got this and to the presentation. And Jan, you'll stop me if you don't see the presentation, please. So I will assume that you can see it. Awesome. So Abstract SDK. So yep, there's me. But in Cosmos, we are modular maximalists. And so the Cosmos SDK and the IBC stack, they are winning. We have hundreds of chains now, and we have many huge projects migrating over to Cosmos SDK because the modularity allows for customizability, it allows for scalability and collaboration between the teams with the modular Cosmos SDK. And this is amazing, but it presents some challenges with the multi-chain environment. And so these are developer challenges as well as user challenges. And I'm going to be focusing on the developer challenges for developers building in CosmWasm, and specifically CosmWasm application developers who are trapped in silos while the users are trapped in chains. So here's a little bit of IBC zones. And so what are the pitfalls of CosmWasm development? So CosmWasm is a fast, scalable, and multi-chain smart contract framework within the Cosmos ecosystem. It uses WASM, and it's amazing. However, there's little collaboration between different teams in the CosmWasm ecosystem. There's insufficient tooling for building scalable applications. We're stuck with the same primitives that the EVM world has surpassed maybe 5 years ago. And so additionally, integrating with CosmWasm projects is costly engineering-wise, and you have to spend a lot of money on an additional audit once you have that integration done. And finally, the integrations with the interchain with IBC requires a lot of expertise that most developers don't have. So in this, I'm going to go over a quick example of an autocompounder, which is something that users can deposit into. It makes a position on a DEX, and it takes the rewards and increases the user's position. And this is a hands-off approach to generating yield in an automated way. So in this example here, you see that we have 4 autocompounders, one for Astroport, one for Windex, one for Osmosis, and another one for Astroport. And now traditionally, all of these autocompounders would have their implementations or their integrations tightly coupled to the implementations. And so I would have to write a new autocompounder for Astroport, given that it's a contract autocompounder, and I would have to write a new one for Osmosis, given that the actual DEX is built on the Cosmos SDK and it uses the native calls. Same for these other 2. So as I mentioned, there's only really 3 functions to an autocompounder. One is depositing, where you provide liquidity on the DEX and receive liquidity provider tokens, which are called LP tokens. And then you stake them to get some external incentives, often offered by the DEX, but sometimes offered by external protocols. Then there's the compound step, where you claim those rewards, you swap them for the assets, and then you redeposit, and you enter that deposit flow again. And finally, when you want to withdraw, you have to unstake those tokens, withdraw the liquidity, and return it to the user. So if you really think about this, there are 6 actions that are being done here, 3 of which are on a DEX, which is providing, withdrawing liquidity, and swapping, and 3 of them are on some staking protocol that could be the DEX. It's usually another contract, or it could be an external protocol, such as another autocompounder. So that would be staking, unstaking, and claiming. And all of these integrations are incredibly painful as a developer. So one, you have to look at the source code, you have to import the packages in your contracts, and then you have to write the integration yourself and test it. And the last one is one of the most difficult parts about integrating with an external service, because their contracts are going to migrate on the chain. Your integrations are going to break. They're going to have some local changes not pushed to main, and your integrations are going to break. They're going to have inconsistent information on the repositories, and it just sucks. And so you get a lot of engineering costs and maintenance costs, and every single project does this from scratch. So what happens if we think about abstracting away the autocompounder, like taking away some of that logic in a Web 2 world? We'd create a couple different microservices. We'd have the autocompounder service, the DEX service, and the staking service. And so this separates the DEXs from the autocompounding logic, meaning that that logic is isolated and your business logic is there. And every single DEX basically has the same actions, right? You give it assets, a spread, belief price, and you can swap, provide liquidity, whatever. And so in Abstract, we have created these things called adapters. And for those of you that are computer science students, you've probably heard of the adapter pattern, which allows for taking incompatible interfaces and slapping them together so that they work. And so, as I mentioned earlier, every single DEX requires a new integration, even though these actions are completely standardized. And so taking an abstract approach to this, you'd standardize the action, give the DEX name, and then you provide the assets that you want to swap. Here we're swapping on osmosis, and we give the asset names, and we end up with the osmosis swap message. And this is a DEX adapter that you can use within your application, right? Okay, conceptually, great, fabulous. And now within the code, in the smart contract, if you wanted to use this in your application, say that you use the DEX service, you have this nice API, app.dex, and then you just say dex.swap. That would be amazing. And then you get this nice swap message down here after you've formed it in the application. So at Abstract, we've performed this abstraction, and we've called it service abstraction, where you can have individual services like the DEXs, like the staking adapters, and they sit, and you can interact with them with the same interface as every other service of the same type. And so this is great, but let's take it one step further. So these adapters are actually modules. And so these modules, you take them and you put them together and you form an application that you can see here. You have a DEX module, a staking module, and an autocompounder module that depends on those two modules and interacts with them to perform the autocompounding actions. And so here is an example of an autocompounder that is built using the Abstract framework. Now I'm coming full circle back to that. So the Abstract framework is a modular CosmWasm framework that provides an approach to building scalable multi-chain applications. And so we've taken inspiration from the Web 2 world, as well as well-studied design patterns in the Ethereum world, such as the diamond proxy pattern, which is used to overcome some of the scaling limits and development limits of the EVM. And so you can see here, for this autocompounder, as on the previous slide, there's an autocompounder that depends on the DEX and staking modules and the vault, which isolates funds. And so you may be thinking, all right, so the vault's another module, and then what's this manager? We're going to get to that later. So the manager allows for interacting with this application, and it manages these modules, makes sure that their versions are compatible, and allows for performing upgrades dynamically. And so these, all of these modules can be upgraded independently of one another, and they may declare dependencies that we're going to go over now. So within the framework, there are many on-chain components to this. And one is the on-chain module registry, which allows you developers to register modules with new versions, and they publish updates just as they would an NPM package. And because this is blockchain, we can allow developers to add some monetization to their modules, which can come in the form of subscriptions or one-time fees completely paid on-chain. And so what this enables is dynamic on-chain application updates. So with this autocompounder here, say that we have a new integration with an integration with a new DEX, or we fixed some bugs. Well, we can tell the application manager, which is a smart contract, to upgrade the modules within it. It'll reach out to the module registry, check the version requirements and whatever, and it'll check the contract's version upgrade checks, which check the dependencies of the contract as well as the compatibilities and making sure that it's actually an upgrade. And then finally, you've got the autocompounder and other associated modules upgraded. So this allows for relatively scalable app development. on single chains, because you can use these modules, put them together to form more advanced applications. So I've got a few of them thrown up here, but in the interest of time, I'll move on. So, all right, what if I told you that every abstract application was also a smart contract wallet? Well, it happens to be the case. So every application is built on this smart contract wallet. It is like this manager and the vault put together, which allows for better isolation of funds because all of the modules are interacting with funds from all over the place, but they really should have one centralized place in a decentralized smart contract where they put those funds, that isolate them and allow for more advanced authentication configurations. And this, of course, is a form of account abstraction when you install an authentication module that would allow for external authentication methods. These accounts can also have sub-accounts, which means that applications can be isolated from one another, and individual wallets can be isolated from one another while still being associated. And all top-level accounts are fully aware of all of the sub-accounts that are under them and can perform actions on them, or the user can perform actions on them directly. And finally, this enables something that we're called self-hosted DeFi, because users can take an application that would be traditionally hosted, like an auto compounder, for example, Beefy Finance or 42 Finance. Those are both hosted applications. And when you build an auto compounder on Abstract, as 42 Finance has, you can pull that auto compounder into your own infrastructure and be in complete control of all of the upgrades and the management of those smart contracts. And that sounds rather complex, but because it's a smart contract account that has dynamic upgrades, it's actually relatively easy as a user. And the reason that you might want to do this is because if you're a large fund, you're not going to be wanting to pool your funds in a public smart contract that's controlled by someone else. You're going to want to have absolute control. All right, so if you take this one step further, which we have, you get interchain accounts. And so this is one of the latest developments of our framework, which allows for building true interchain applications. And this means that as a developer, you don't have to write custom IBC protocols that get listed into the IBC spec. At first, when you're trying to write an application over IBC, you can do it directly in CosmWasm, interact with multiple chains, go multi-hop accounts, as well as interacting with ICA accounts, as will be presented by Serdar later today or in another session. And so what this means is that you can take the idea of a Mars outpost model where you have one hub, the hub and spoke model, you have one hub and many spokes, and you can expand it even further because all of the outposts themselves can have outposts, of course, ending at the ICAs, which are like leaf nodes and cannot have further outposts. And this enables a slew of fun and exciting interchain applications like auto compounding across IBC, as well as like a staked asset ETF where you deposit into it and it IBCs the assets into it across every single chain, and or something that we built a few years ago, which is a cross-chain auto-balancing ETF. So ultimately, what this means from a user's perspective is that they don't care about the chain at all. And of course, this has been a hot topic for a while now. But with these smart accounts, as well as these interchain applications, the user really doesn't need to know anything about the chains that they're interacting with, whether the application is multi-chain, and the developers don't need to think about doing these multi-chain interactions because it's just almost exactly the same internally as a cross-contract call. And so in this example, we are on Osmosis, and we're requesting all of our liquidity from every single chain, and we're recalling it back to our home chain like a liquidity vacuum. And now, wouldn't this have been nice during the Terra crash if you could just vacuum and unstuck all your positions over IBC? But yeah, this is enabled with interchain abstract accounts, and there's Barbie on there from a previous presentation. So watch that if you if you're interested why there's Barbie. So I'm not sure how much time I have left, but I'd really like to give a sneak peek of building on Abstract. So as a developer, I'm going to go over this really quickly. But so the first thing is that we have defined a more readable way of including the entry points into your application, which you can see here with the all entry points listed here, as well as redefining the way that replies are done within the SDK, which allows you to do new number to function. Additionally, you'll notice that there's a dependencies section, and this allows you to take dynamic dependencies on other applications or other modules within your application, and they are able to be upgraded dynamically. So static dependencies upgraded dynamically. And now when you're using the SDK, we saw this earlier, but you can really easily interact with any module that's installed on your account through a trait-based API that we have within our framework. And this works beautifully with CW Orchestrator, which will be presented by a fellow team member, Nicola, later today. So deep dive on that later. And so I've only shown a little fraction of the abstract app platform. I've shown you gone over the smart contract framework, the contract accounts, and yes, and the module registry, which is the wrong things here. But thank you for listening. And if I have time, I would love to go over the account console, and I'd like a confirmation from Jan.
Yeah, like maybe do it as quick as possible.
Yes, as quick as possible. All right, so we have the developer console, which allows you to manage your abstract accounts and your abstract applications. And this is completely live on almost every single CosmWasm mainnet right now, as well as most of the test nets. So right now we are in dev mode. So it looks a little nicer in user mode, but let's go back to dev mode. So in here, you can go manage the modules that are installed in your accounts. You can create sub-accounts. You can interact with the adapters. You can also see the module registry, as well as including monetization options for your modules. There's the abstract name service, which allows you to resolve assets. As you can see here, Cosmos Hub Atom, which would be Cosmos Hub 2 Atom, or Cosmos Hub Atom. And if they're multi-hop assets, you can see here, if it goes from Ethereum to Axelar and the end result is wrapped Ethereum, then you can resolve these assets via a nice and human-friendly name. This is the same with contracts. You can resolve, in this case, staking contracts, as well as channels. So all of the IBC interactions are abstracted away from the user and the developer, and you don't have to care about the channels. We keep them updated to be the most canonical channels that there are. And any breaking channel changes will be a separate deployment, as well as DEX pools. We support Astroport, Osmosis, Astro Vault, Windex, TerraSwap, and a couple other dexes that I can't remember. And all accounts can be namespaced. As I mentioned, they are smart accounts. And since I don't have very much more time, I believe that is it. So thank you so much for checking out what Abstract is, and we're excited to have more interchain applications in the Cosmos ecosystem, and really highlight the fact that we have the most powerful tech stack available in Web3. So thank you. My name is Adair Kelley, and I'll see you next time.
Thank you so much for the presentation.